Hey everyone, and welcome. Today, we're diving into a question that's been at the heart of computer science for, well, over half a century. How in the world do you build a machine that can actually think?
No, I'm serious. Just think about it for a second. If it were up to you, where would you even start? It's a huge question. And for decades, this exact problem split the entire world of artificial intelligence into two totally different rival camps.
So on one side, you had this idea of building from the top down. You treat the machine like a brilliant student and you meticulously program it with all the rules of logic and knowledge. But on the other side, you had a completely different philosophy, a bottom-up approach. Forget the rules. Instead, build a system that learns on its own, kind of like how a child learns about the world just by experiencing it.
Now, for the longest time, that first path, the logic path, was really the only game in town. This was the era of what we now call symbolic AI. The dream was to literally construct an intelligent mind by carefully writing down every single rule you could think of.
And you have to understand, the optimism back then was just off the charts. Pioneers like Herbert Simon were completely convinced that a true thinking machine was just, a decade or so away. They really felt like they were on the verge of cracking the code of the human mind itself.
And look, they had the wins to back it up. The term artificial intelligence gets coined in 1956, and just a few years later, you have programs solving college-level calculus, acing tough algebra word problems, and even doing machine translation that seemed like absolute science fiction at the 1964 World's Fair.
So the key idea here is that symbolic AI sees intelligence as this incredibly detailed blueprint. Every single concept, every fact, every little relationship, like a canary is a bird, or a hand has fingers, has to be explicitly spelled out and programmed into the machine as a hard and fast rule.
But this beautiful, clean, logical dream was about to smash headfirst into the messy, unpredictable, and deeply illogical real world. This brilliant idea was about to hit a very big and very human wall.
And this led to a puzzle that just totally baffled researchers. It's called Moravec's paradox. And it goes like this. It turns out the things that are super hard for us humans, like mastering chess or solving complex calculus, were surprisingly easy for AI. But the stuff we do without even thinking, like recognizing a friend's face, catching a ball, or getting a joke, well, that turned out to be nearly impossible for a machine.
The issue wasn't a lack of computing power or bad logic. The problem was common sense. How do you write a rule for what makes a joke funny? Or for knowing that even though a penguin is a bird, it can't fly? The real world is just built on top of millions of these unwritten rules that we all just know.
This massive roadblock was so bad it led to not one, but two different AI winters, long periods where the funding just dried up, progress stalled, and the whole field got pretty cold.
But just as that dream of pure logic started to fade, a different, much older idea was waiting in the wings for its moment. An idea that wasn't inspired by the clean rules of a computer program, but by the messy, tangled wiring of the human brain itself. And this is the artificial neural network. It just completely flips the script. Instead of feeding it rules, you create this web of interconnected nodes, kind of like artificial neurons, and you just show it data. Tons and tons of data. And the network's job is to figure out the patterns and make the connections all by itself.
Okay, here is a really great way to think about the difference. Symbolic AI is like a perfect librarian. It knows every single rule in the entire library, and it can follow any instruction you give it perfectly. A neural network, though, is more like a detective. It doesn't start out knowing the rules. It learns to solve the case by studying thousands of past examples, and over time, it develops an intuition, a feel for the pattern.
But for most of AI history, this detective was basically stuck in a cold case file. The whole idea of neural networks was seen as this kind of fringe, wacky concept because it was missing two absolutely critical ingredients that, well, the world just hadn't invented yet. So what finally changed? What was the spark that finally unleashed the power of these learning machines and really kicked off the AI revolution that we are all living through right now?
All right, so what were those two missing ingredients? What finally happened that allowed this underdog idea to not just compete with the old guard, but to pretty much take over the entire field of AI?
Well, it was basically a perfect storm of three things coming together at once. First, the internet. All of a sudden, you have this endless ocean of data, text, images, you name it, for these networks to learn from. Second, raw computing power just exploded.
Our processors finally got fast enough to handle the insane number of calculations these networks needed. And third, researchers came up with way smarter algorithms, like something called backpropagation, which gave the networks a really efficient way to learn from their mistakes.
And when you put those three things together, the massive data, the incredible power, and the smart algorithms, boom, the era of deep learning was born. We finally had machines that didn't just follow our rules, they could actually start to teach themselves.
And the results were just stunning. Suddenly, all those problems from Moravec's paradox, the things that were supposed to be impossible for computers, they just started to fall one by one. Google's DeepMind taught itself to master old Atari games without any instructions. Facebook's tech got so good it could recognize faces with almost human-level accuracy. And the voice assistant in your pocket, it went from being a clumsy gimmick to something actually useful almost overnight. So this all brings us to a final, really fascinating question. You see, the first dream of AI was to build a machine that thinks like us, using our logic and our rules. The new reality is that we've built a machine that learns for itself, often in ways we don't fully understand. So what does it mean for our future when the things we create can develop skills we never actually taught them? That's definitely something to think about. Thanks so much for tuning in.